Hi, welcome to the Trig Unit, Lesson 7, Solving Problems with Trig. Okay, basically this lesson is mixing up the problems you've learned so far. So let's jump in and get moving. You should know everything. Now it's just putting it, mixing it up, and deciding which strategy do I use. Okay, so let's go through and write our ratios. The more you write them, the more you'll learn them. So the sine is our opposite over our hypotenuse, or SOH. Cosine is adjacent over hypotenuse, or CAH. And then tangent is our opposite over our adjacent, or TOA. So we have SOH CAH TOA. So use that as your reference as we go through these problems. Okay, now we're going to jump down here and start running through the problems. And you're going to ask yourselves these questions right here. Is this a forward problem or a backwards? Forward when you're looking for a side, backwards when you're looking for an angle. Which sides do I have to reference, or which sides am I looking for? Once you know that, then you can decide which trig function am I going to use depending on which sides I have. Then we're going to set up and solve each of these problems. So let's start with this first one here. Okay, we have a 90-degree angle here, a side x 56, and then an angle that measures 37 degrees. Okay, is this a forward or a backwards problem? Hopefully you said forward because we have the angle. When you have the angle, it's a forward problem. Okay, which two sides are we dealing with? I always like to label my opposite first, then my adjacent leg, and then my hypotenuse. So I'm not using hypotenuse on this one, so I'm using opposite adjacent. Which one is opposite adjacent? Tangent. So I'm going to take the tangent of the angle, and the angle's given, 37 degrees, is equal to the ratio of opposite over adjacent. So my x is on top, because it's opposite, and adjacent is on the bottom, because it's given. Okay, now let's talk about how, slide this over, there we go, so you guys can see it. Now we've got to solve it. Okay, so if you remember, when we're working forward, we actually have to change that tangent 37. Well, let's stick a 1 under it first. And then we're going to do a cross product. So let's change that tangent of 37 to a decimal. So I'm going to just go forward and take the tangent of 37 degrees, and I'll close my bracket. And I get 0.7536. So 0.7536 all over 1, and now I'm going to work my cross product. So when the variable's on top, it's a little easier because x times 1 is just x, and then 0.7536 times 56 is 41.2. So I'm going to get 42.2, excuse me, 42.2, and that's how long this side is over here. And there you go. And that's how you find that missing side. Okay, so there's our first one, and that was a forward problem because we were given the angle. Let's look at the second one. Okay, on this one, we're given an angle of 90 up here, an x here, 18 and 22. Okay, we do not know the angle. So this is going to be what, a forward or a backwards problem? Hopefully you said a backwards problem because we don't know the angle. So we're going to have to work this one backwards or use our inverse button, right? That x to the -1 or sine to the -1, cosine or tangent. Okay, so which two sides do we have? From the angle of reference, we have the opposite. This is the adjacent, and this one's the hypotenuse. Okay, we're not using the adjacent. So which one uses opposite hypotenuse? Go back If you don't know your trig functions, opposite hypotenuse is sine. So we're going to use a sine. The sine of what angle? Well, we don't know it, so that's our x is equal to the opposite, which is 18, over the hypotenuse, which is 22. Okay, now since we're going backwards, we're going to have to use that inverse button. So I'm going to do the second sine to get x or sine to the -1 of 18 over 22. So let's type that in. Clear out here. I'm going to zoom out just a little bit to help you guys. Zoom out. There we go. That helps a little bit. Makes my screen a little bigger. There we go. Okay. Second and sine of 18 divided by 22. And that angle is what? 35 degrees, right? 34.9 would round to 35. So x, I'm sorry, 55 degrees. So it's 54.9 or 55 degrees. So that means this angle right here is 55. But just thinking through, do you remember how do you find this other angle? Well, we know that two acute angles add to 90. So we can take 90 minus 55 and know that this angle over here is 35. We weren't asked to find that, but just remember that's how you do find that one. Okay, so let's look at the next page. We've got two more problems. See if we can find these missing parts here. Forward or backwards, that's what you need to be asking yourself. Okay, you've got an angle of 44 degrees here, an angle of 90 here, an x and a 66. Since you have the angle of reference, this is going to be a forward problem. So you're not going to use your second function key, you'll just use the regular trig, sine, cosine, or tangent. Which two sides? Okay, opposite. We are using adjacent and hypotenuse. Okay, which one is adjacent hypotenuse? Go back. Adjacent hypotenuse is cosine. So we're going to take the cosine of 44, and that's equal to the adjacent, which is our unknown x, over our hypotenuse, which is 66. Now let's do some calculator stuff. Let's take your cosine of 44 over 1. So grab your calculator. Cosine of 44, and it is 0.7193. 0.7193 over 1 equals x over 66. Do my cross product, so I'll just take that answer times 66, and I get 47. So x is 47, and that's 0.47, but I'm looking at the tenths, and the tenths does not round up, so that's just 47 degrees. So, I'm sorry, 47, this is not an angle, it's a measurement. So it's just 47. Okay, that's how you'd work that one. So that one was a forward problem. Okay, let's look at the fourth one here and see if we're missing an angle or are we missing a side. Okay, on this one, I'm just going to zoom this one in. Try this one on paper here. It's my last one. There we go. Okay, I've got my reference angle here, and I don't know the angle. So is this a forward or a backward? This one is a backward problem. We're looking for the angle. Okay, so which two sides are we using? This one is the opposite. We're not using it. So which trig function uses adjacent hypotenuse? Hopefully you're getting more comfortable with that. The answer is cosine. Cosine of our unknown angle x equals the adjacent, oops, I've got those labeled wrong, don't I? This one's hypotenuse. This one's adjacent. Okay, so let's rewrite. Let's make sure we set the ratio up right. Adjacent is 71 and hypotenuse is 79. And I think I would have noticed that because we know that the hypotenuse is always the longest. Okay, so now we work backwards. So let's take our handy dandy calculator. Boy, we're zoomed in way too far here. There we go. Okay, so let's clear and take the second function cosine to get our inverse of 71 divided by 79. And the answer is 26 degrees. So x is 26. Okay. Had I done it wrong and put the 79 over 71, it actually would have come up with an error because cosine can't, the ratio of cosine can't be greater than 1. So it would have given me an error anyway. Okay, so those are 4 practice problems. Now what you're going to do is you're going to try this one. Okay, a couple of leading questions. Which sides do you have? Which trig function are you going to use? Set up and solve it. Since this is an inverse section, you may want to decide, is this a forward or a backwards problem? Figure out which one you're going to do before you start, and that kind of helps you out. So the answer will be in the course. So good luck, and I hope this video helped.